Let's look at this WASSCE Nov-Dec 2025 Section B Theory Question 13B. This is the circle theorem, and you know that when it comes to WASSCE Nov-Dec, they will never leave circle theorem out of it. So let's look at this question. I'm going to break it down easily for you to understand, okay? So that even if you don't meet this question, you meet it anyhow or anyway, you'll be able to know how to deal with it. Now the question, this is the diagram, and the diagram they have drawn here, they have put it in that description over here. That is how it is. Whatever they draw, they will put it in the description for you. So in the diagram, NRS, that is this, NRS are points on a circle. So they are points on this circle. Good. MP is a tangent. MP is a tangent. I'll explain that to you later. To the circle at N, meaning that it is meeting the circle here at N. I'll explain to you later on, so relax. If NR is equal to RS, if NR is equal to RS, and there's something that is showing that even if they don't write it here, but I'll show you later on, and angle SNP is equal to 74 degrees. Angle SNP is equal to 74 degrees. Find angle RNS. Find angle RNS. Mean that you are finding for the angle over here, right? Good. Now let me show you something, even without a description over here. First of all, knowing what you are supposed to find is RNS, mean that you are finding here. Now when we look at the diagram, we have seen that within the circle has a particular triangle inside, and there are strokes here. Now in triangles, anytime you see strokes there, it means that the base angles are equal, meaning that if here is x, here will be x. Simply meaning that if here is 50 degrees, here will also be 50 degrees. So these are the signs that are supposed to tell you. So even if I draw my diagram this way and I make my stroke over here, where are the base angles moving? Down here. So it means that this angle and this angle here are also going to be the same. That is the idea about this particular sign over here. So it is trying to tell and give you idea. The moment you see that, it's giving you a clue. Oh, okay. So since it's telling me to find for angle RNS here, then it means that what angle I'll get here is the same as the angle that is here. So you let me even put them, say here is A. It means that here will also be A. As simple as that. Good. So it simply tells me, okay, if this place is A and this place is A, then if this is a triangle, then when I find this place will be easy for me, because after finding this place, I'll subtract it from the total interior angle of a triangle, and that will help me to divide it for it. So the idea is that therefore I need to find this place. That is all about the question. Finding this place will make this place easy for me. So how do we go about that? Here is a circle theorem, and because there is a tangent here, the moment you see a line over here, it should give you a clue that you are going to use the circle theorem law that has to do with tangents. And that law says that the angle that lies between a tangent. Now what is a tangent? A tangent is a straight line. Okay, good. The point at which a straight line meets a circle. So this is a straight line, this is a circle. This point where they meet is what is termed as the tangent. That is what they are trying to say over there. So this is the tangent. Good. And he said that the angle that lies between a tangent and a chord. Now what is a chord? If I have a circle, chords are only formed within a circle, right? Let me clean this triangle so that you follow it very well. Chords are found within circles. So when I have my circle this way, a chord is a line segment from one end of the circumference of a circle to the other. So the space that is found over there is what we term as the chord. So this is a chord. I can also have a chord here. This is also what? A chord. As simple as that. So if I have something like this and I draw this particular segment A, B, this is the chord. That is a chord, as simple as that. Therefore, it says that the angle that lies between a tangent, and I've explained to you already, the tangent is talking about the point at which a straight line meets a circle. So it is meeting it here. And it says the angle that lies between a tangent and a chord. So let me draw this chord well. So let me say this, I have a chord here, I have a particular chord here. Good. So this is a chord. You know this place is a chord, right? Good. And it says that the angle that lies between this tangent, the point over here meeting, and a chord. This is the chord AB. This is the tangent A. Let me say CD. So the angle is forming over here. So it is talking about this angle over here. That is what it's trying to talk about. So the angle that lies between a tangent here, where the line is meeting the circle, and a chord, this angle of forming is over here. Good. Is equal to the angle subtended by the same chord. This is where most of you get confused. This subtended, okay? Let me underline the main idea. Subtended simply means that this chord we have AB, I am going to stretch it for them to meet at the opposite side. So I have stretched it and they are now meeting here. This is the chord of AB. So the point where they touch the circumference, I'm going to stretch it. So when I stretch it, they are meeting here. That is what the term is subtended by the same chord. And this is the chord, you know, I've told you already. The 2 points, when a line is drawn, the point that falls on the circumference is the chord. So when I stretch it, for them to meet, that is what they term as the subtended by the same chord. It says that that particular chord is equal to the angle. It's equal to the angle subtended, stretched by the same chord. So when I stretch this chord, it forms an angle over here. And it's saying that the angle that lies between this tangent, I getting it, and this chord over here, this angle over here, if it's A, is the same as the angle that will be formed when I stretch this chord to the other side, meaning that here to become A. That is the meaning of this plenty English. So if here is A, it is trying to tell me that here also becomes what? A. You see it? So now look at the diagram over here. This is the chord, right? And this is the tangent, and this is the angle it is forming. So when I extend this chord and they are meeting here, what is the angle forming? Here. Simply telling me that if here is 74, here to be 74. So when you picture it this way, you can put an alphabet there. Simple. So I'll put X there, and that will help me to make my working easy, right? I hope you are following. Good. So let's move on and see how it will be. So now that I know this law, that this part is the same as this part, now it becomes what? X is equal to the same 74 degrees. And that's why you write the law. The angle that lies between the tangent, this, and the chord, this angle over here, is equal to the angle subtended, the angle stretched by the same chord. I get it in the alternate angle, So this angle. So that's why X is equal to 74. If you want to use the vertices, the names of the segment, the point, you will say that angle S R N is equal to 74 degrees. That is if you don't want to put any variable, the alphabet there to represent it. You want to use this point. You can do it this way. So now I know that this place is for 74 degrees. It's going to make my working easy. So you let me draw the triangle again so that you see how it is going to be now to make our working easy. Okay. So right now we have it this way. So we know here was what? 74 degrees. Now we know that this place, we have found it, which is the same as 74 degrees by the law. So this sign, I've told you already, tell that here and here will be the same. So I can use X to represent it. No, I use X for here. So let me use A. A to represent it, then here to A to represent it, right? And you know this is a triangle, right? And you know that triangle, whenever you add it, you are going to get 180 degrees. Good. So it's going to be what? 74, let me write it so, 74 degrees plus A plus another A is equal to 180 degrees. Which is that you write total interior angle of a triangle. I've just made it in the initials. So we move on to make it 74 degrees is equal to 2a is equal to 180, plus 2a is equal to 180 degrees. So 2a is equal to 180 degrees minus 74 degrees. So you are going to get 2a is equal to, when you subtract, what are you going to get? 106 degrees. Then 2a is equal to 106 degrees. We divide both sides by 2. So we are going to get what? A is equal to 53 degrees. And this will become the answer for this angle. Why? Because if I have here RSN and say find angle RNS, this angle RN is the angle that forms over here. So I will just, after I found my A, I know that it's 53 degrees. I'll just come and say, therefore, angle RNS is equal to 53 degrees. And that will become your answer for this. As simple as that. You see how it is short? Just short. Then you are gone. Get your full mark and go. So you need to understand this particular law concept, picture it, and see what you use around it before you start. If you picture it, you get it, then you are straight to go. If you don't want to use the A and A, you want to use the RNS, you can still use it. I getting it, because you know this angle will be the same as this angle. So the angle I'll get at RNS will be the same as this angle RSN. So you can make it even the 2. If you don't want to use 2 RNS like this, it's equal to 106. Then you divide both sides, so 2 angle RNS. So you divide both sides by 2 like this. So these two will cancel these two will cancel here, and you get 53 degrees. And I'm still going to get angle RNS is equal to 53 degrees. So this is how we did with it. If it's your first time watching me, follow me for more tutorials like this. And you have any topic you don't understand, follow. I'm going to go through all of the questions for you to understand, to prepare you and give you the hints of how to pass your WASSCE. My YouTube channel is on my bio. Follow for full lessons on some of these topics and everything for you to get an understanding. We'll meet again.